So Miss B's coming at some point. I don't know when. When she comes in, we'll just pause and check the calculators in.
Yes, sir.
So I kind of screwed up yesterday, and I told you I'd put the answers on during my conference hour. And I forgot. I didn't get them on until like 4 or 5 o'clock or so.
I still found them at 11.
So yeah, if you looked late at night, you're fine. But if you tried to check like right after school, they weren't there. I apologize for that. So I'll go through it and just stop me and tell me to go through them. Number 1 C, number 2 is B.
Number 2, please.
Number 2. Number 2 is designed to be just a mess. There's no factoring you can do to like cancel out the trig function. There's no rationalizing you can do to get rid of that trig function. You just have to deal with the trig function. But it's the way that answers are written does make your life easier. So if you notice, the first thing I'm going to look at, so here it says f of 1 doesn't exist because it says nor f of 1 exists. Here it says f of 1 does not exist. These two, they say f of 1 does exist. So the first thing I did was, okay, does f of 1 exist? Can I plug in 1 and get an answer? And if you plug 1 in to this equation, so that's probably the thing that makes most sense to start with. They're asking about x equals 1, right? Let's just plug in 1 and see what happens. And if you plug in 1 on the top, there's no trig there, so you guys can probably do that. You get 0. On the bottom, we should probably talk through the trig real quick. So if I plug in 1 for x, what's negative pi over 2 times 1? It's just negative pi over 2. So x doesn't even really mean anything, What's pi? How many degrees is pi? 180. So pi over 2 is 90. It's negative pi over 2. So it's negative 90. So you go backwards 90 degrees to here. And sine is the x or y value. The y value. So what is that? Negative 1. So this becomes 3 times negative 1. And then over here, what's negative 1 squared? 1 times 3. It's 3. So you get negative 3 plus 3. So you get 0 over 0. 0 over 0 means what type of discontinuity? Removable. So in a removable discontinuity, does the limit exist? It does. The limit exists. When I plug in, it doesn't exist. Yeah?
Doesn't 0 sometimes mean indeterminate? Like, you just have to do more to figure it out.
That's just another way to phrase like a removable discontinuity. Yeah, so it's the same thing. Does that help for that one then? Three and 4. So B and C there. Questions on those two? Okay. Miss Me's here, then we'll. Oh, you're good. I already have the gravel, so.
Kids keep stopping me.
Rude.
So,
Go ahead and check them in.
ask
What?
me questions. Sit. Like, too late.
I think the best thing anywhere is like 5 total ones. Because they're like the closest natural. I'm not saying overshoot. I'm just saying our presence. Don't be like, this grenade was still cool. Yesterday was a barefoot, I broke my ankle and I was suing them. Where's Mr. Overy?
Imagine like coming to school and everyone takes their shoes off.
Okay, I'll come back with the straight.
Everyone's like,
Sorry,
Protect the market.
What's that purpose? That's fair.
don't think he's
Valedictorian.
Yeah.
Well, I'm
Not trying to be mean. Where are you? What's your like?
I was singing along. I was walking away singing.
What's that?
That would have been so fun. I'm gonna make
Yeah.
Yeah, which one? I like to see your number.
Why? I know. So familiar.
If you jump past 40 people, that'd be the best.
As soon as I get that sheet, I'm gonna bring it right to you.
It says you last rank.
But I'll probably not forget about it. Okay.
3003837.
Yeah. Almost come off cash.
I forgot to pause the
Does yours
recording.
have a piece of tape over the barcode?
Josh is out here. I guess he gets on the video.
Maybe made up a number. I don't know.
Does that have tape over it?
You'll see him here if you want to. Thank you. Alright. So, I got a request for 3 and a request for 4. So in 3, we look at so we factored it. We're trying to find out if it's continuous. So we're going to look at, they did it the style where you factor and cancel instead of like setting the bottom equals 0. So they factored, then they crossed these out, and they're like, okay, we're just left with x plus 3 and x minus 5. And I can plug in that to get what the limit is. Oh yeah, I guess they're not even asking if it's removable or not. So this is your limit. And then they went to plug back into the original equation, because if something's continuous, what has to be true about the limit and the f of whatever? They gotta be equal, right? So they went to plug back into the original equation to see what f of 2 was, but did they plug back into the original equation? They did. They plugged into like the factored version, which is not the same. It's not going to result in the same thing. So that's step 3 is where they do that. So they should have plugged 2 back into here. So what would you get if you plug 2 back into there? 0 over 0. When you plug into the factored version, you get an actual answer, but that's not really the true answer at that spot. It's technically 0 over 0 and you determine the right number. Is that alright for 3? There were a few people that said 3. And then 4. So which of the following statements is false? And then give me there. I gotta check all of these spots though. So I'm just gonna start plugging in things as like so for x is less than 1. So I'm gonna plug 1 into here. What do I get? 3. And then add x equals 1, I get 3. And on this is on the other side of 1, so this, if you flipped it around, really says like x is greater than 1, doesn't it? You just like rearranged it. So plug in 1 here, and what do you get? 3. So at 1, everything's 3. So it is continuous there, so that's true. And they're asking which one's false. At x equals 2, well, I don't even have like a mismatch or 2 rows there. I'm just going to plug in 2, and which, if I number these equations, letter these equations, a, b, c, d, and e, which one do I plug in if x equals 2? C, because that's where this is. And plugging in 2 is going to get you some number, and there's no roads to connect it. You're just going to get a number, so everything's fine. That's fine. At x equals 3, now I got to check these 3 rows. So if I plug 3 in here, 3 cubed is 27, plus 3 squared is 9, so 36 plus 3 more is 39. Well, what's the actual value of x equals 3? 0. So if the limit, I got a row that put me at 39, I've got a bridge at 0, and then I've got another road at 7. So this is, I forgot, this might be like Noah's, where there was a road that went here, a road that went here, and a bridge in a completely third spot. Just like the worst construction I've ever seen. Was that Jocelyn?
Not just a second.
Noah didn't even make a bridge, did he? So this is actually better than Noah's. Yeah. At least you made a bridge, you just put it like in some random position. So that is not continuous there, so does that help?
Yeah, thank you.
5 and 6. So these are kind of repeats, right? So if you asked about 5, or if you asked about 2, you essentially also asked about 5. What's the problem here? What I'm saying is I'm not going to do it yet. Now that I've shown you 2, try 5 again, and then I'll talk through it. You know what I mean?
Yeah, got it. I get that.
All right then. Glad you understand. And same with 6. Like we went through 3, so if you might have like picked something up from that. So if you missed 5 or 6, try them again. See if they make sense to you now. If they don't, happy to go through them, but it's better if you look at it than me doing it. So for 5, they're asking about the x value of 2. So I'm going to plug 2 in and just kind of see what happens. And there's no way to factor anything here, so you're just stuck plugging in and you're hoping that gets you one of the answers. And it will, because they realize that they're setting it up that way. And if I plug in 2, what do I get? 0 over. Should I talk through the trig part? No. Please do not talk through the trig part. Well, mine said no, so. Plug in 2 for x. So what's pi over 2 times 2? Pi. Pi is how many degrees? 180. Well, 180 is over here, right? Cosine is the x value or the y value? The x value, what is that? -1. So we've got 8 times -1 plus 2 times 2 squared. -8 plus 8, so you get 0 over 0. And if it's 0 over 0, there is a discontinuity there. And what kind is it? Removable, which means what does the limit exist or not? It does. So the limit does exist, but f of 2 does not. How many were able to get that after I explained 3? Like it made more sense. Okay, cool. 6 is good. Is 6 good now, or talk through it again? 6 is good. We're good. All right. Next page, CA. I told you to skip 8. We're gonna talk. We'll just talk through it together because you just don't know what the words mean. We can use the rest of the problem. Is 7 okay? Like that. So now there's the other one.
Yeah.
Okay. All right. So 8. You don't know what differentiable means. That's coming in like a month, but we can look at the rest of them. So just let's pretend these 2 were true/false questions. 2 and 3, or 1 and 3. Tell me whether those are true or false. No, let's do this. No, not true or false. This is way better. Always true. Always false. Sometimes true. Decide that for like options 1 and 3. So if the limit is 7, does that mean it has to be continuous at that spot? It doesn't, but could it be? So it's like sometimes true, right? So this is like, I guess, S for sometimes. I want you to try to draw, we're not moving on to number 3 yet. Draw a situation where the limit is 7, but it's not continuous. Make a quick sketch. Where the limit at x equals 3 is 7, but the function is not continuous there. Don't make like a fancy graph, just a quick sketch. What type of discontinuity did you just draw? Removable, because the limit has to exist, but then the bridge is in like a different spot. So that's my quick sketch. Does that make sense? Part 3, if the limit as x approaches 3 is 7, does that mean that, so I would phrase this as, does that mean there's a bridge at that exact same spot? Not necessarily. Could there be? Yeah. Draw this, where the limit is 7, but the, well, it's the same drawing, isn't it? Yeah, never mind. So that's sometimes also. So your limit would be 7, but the half of 3 is in a different spot. Okay. Next page. AC. Also the answer to what was not working the first week of school. Also, it might not be working right now. Kind of work.
We're all.
Oh.
So those two okay? Number 11, the answer, or the question's on the front, the answer's on the back, but so the limits are not equal, so it's not continuous. Like each side gives you a different thing when you plug in, so it's not continuous. And then 12 is A, 13 is E. Those all right?
I got yes.
I got ya.
I got yes.
Oh, wow.
Did you plug in 3?
3 plus 1 is 4.
Square root of 4.
In my head, 3 plus 1 was 5.
Oh.
Wow.
But it says 6 on your.
But no, it was 6. Yeah, that's even, yeah, 3 plus 1 was 6.
So wait, in your head it was 5. Then you
I don't know.
You're right.
I'm telling you, you don't want to know what's in my head. So the square root of 4 is what? 2. So it's actually yes. Alright, my bad. So who wants to go over, who needs to go over number 11? Me. 12 and 13, okay?
13.
Talk about 13? Okay. So if there is a limit, you guys don't know what A means, so don't worry about that. It's a derivative, and the derivative, it's saying the derivative exists, but we haven't really talked about when that is. Just because there's a limit at a spot, does that mean it has to be continuous there? No. Just because there's a limit at a spot, does it mean there has to be a bridge there? No. Just because there's a bridge or a limit at a spot, does it mean that the function has the same value at that spot?
Yeah.
No. So none of these above are true. Does that help? I can like draw them out. So if I give you something like this,
I think it's the limit of as x approaches a that is confusing me.
so just imagine A is some number.
Okay.
So just put in numbers. If the limit as x approaches 3 of f of x is 10,
Okay.
does that mean that f of x is continuous when x equals 3?
No.
Does it mean that f of x is defined when x equals 3?
No.
Does it mean that f of 3 equals 10?
No.
You know what I'm saying? So if you
Yeah,
just
yeah.
kind of throw numbers in that spot, it's
Okay.
easier for your brain to. Alright. 14 is E, but I don't even want to spend time on this. I barely care about it. E for But how many got it? I'm just curious. You just gotta know what those graphs look like. And that's not too worried about it. So ln of x goes like this. E to the x goes like this. And then like a combination. I don't want to. I've already spent. I don't want to spend too much time. It's not
Am I just know that?
kind of. I mean that's the thing. Like, but it's not gonna really impact your score. You know? So the next one. So this is number 15. The answer's like on the next page. 15 is D. Is that one okay? 16 again. It's on the next page. 16 is B. 17 is A. BA. Also the answer to what is Mr. Davis. B
Oh.
Yeah.
Oh,
Bam. That was okay.
oh, I got that. Oh, that is.
Took you long enough. 18 is B. That okay?
I like to
Watch your
spell
mouth.
it.
I didn't
Where'd
say
the
it.
M go?
18 good? B is also the answer to what Shield aspires to. The grade Shield aspires to.
Yeah.
19 is C. That's probably the grade Shield aspires to, actually.
Yeah.
Yeah. B was setting our heights too high.
Yeah.
Setting our sights too high. And 20 you can skip. And 21A. 22D. That's the AD. We hired a new blank this year. He looks like he's should be in my 4th hour or something.
Yeah.
So he doesn't. Alright. Questions on anything here? Got your notes, please.
Well.
What?
I thought you wanted to check it.
I did not.
You fooled me.
It could be the last time this year that I fool you. So if you don't know if I'm gonna check or not, you're stuck just kind of doing it, right?
Yeah.
See how I do that?
I thought you said yesterday. I'll check it tomorrow.
Sometimes I lie.
Sorry.
This happened. So one time in college, this was a psychology class. They do weird stuff in psych classes.
Yeah.
But this isn't your.
It's been a long.
So do you have lunch right now? Is that what you're?
Yeah.
Okay, I'll see you next time. The professor got up and said, I forgot how I got on this topic, but he said, he gave us 20 statements, and he said there is a lie on this paper. Or 20, there's a lie. I've lied to you once, and he gave us these 20 questions. Find the lie. And the lie was that there wasn't the lie. So but nobody got it. We're all reading through these 20 questions, everyone's arguing, I know that's true, no, that's true. And then at the end of class, the lie was that there's no lie. But I just got you guys to argue about stuff, and you learned it. It's kind of interesting. Yeah. Yeah, it'd be fun as a teacher. For
Yeah.
Sure. Okay.
Sorry.
Horizontal asymptotes. First of all, you can cross through horizontal asymptotes. Because they only apply at x approaching infinity and x approaching negative infinity. It means the graph levels off approaching a certain y value. So the graph can only level off all the way to the left or all the way to the right. And in between there, you can cross through it as many times as you want. So you could have, for example, a horizontal asymptote down there and a horizontal asymptote up there. And it levels off over here, but then it crosses through a bunch of times maybe and levels off over there. So this is as x approaches infinity, and then this would be as x approaches negative. Say this is 3 and negative 4, so you have a horizontal asymptote of y equals 3 and a horizontal asymptote of y equals negative. Could you have only one horizontal asymptote? two ways that can happen. It could be a horizontal asymptote that only applies in one direction. So something like this. Like there's not a horizontal asymptote to the left, right? Because that's not leveling off, that's just going up. But there's a horizontal asymptote over here. Or could the same horizontal asymptote be applied twice? You know, say it's something like this. It's only one asymptote, but it applies at each side. Could there be a graph with no horizontal asymptotes? Yeah, like y equals x, y equals x squared. You know, those just go up or down or whatever. Okay, so, I mean, one thing you gotta be able to do is look at a graph and tell me if there's a horizontal asymptote, but I think that's fairly simple, yes? Okay, and then algebraically is the bigger issue. But what you need to understand is horizontal asymptotes are limits because the equation is going to be a y value, right? I know that drives some people crazy when I spell limits wrong, but again, we're looking at y values. As x approaches plus or minus infinity. So we're going to kind of plug in infinity. I'll show you, but you're not necessarily doing that. I'll just show you what I mean by that. There are three scenarios. All involve fractions. If there's no fraction, there is no horizontal asymptote. There has to be a fraction for there to be a horizontal asymptote. One, higher power is on the bottom of the fraction. And one of these scenarios doesn't even have a horizontal asymptote. So I want to kind of explain to you why this is going to work, and then I'll just tell you the rule, but I think you're more likely to remember the rule if I show you why. So let's say I said to you, find the limit as x approaches infinity of 3x squared minus 4x plus 5 over x to the 5th plus 17. So remember that you're plugging in, you're thinking about plugging in a gigantic number. I mean, like trillion, billion, zillion, Google, the biggest number you can think of. So all that's relevant is, did you guys do this? Okay. All that's relevant is the actual highest power. Because if I take a gigantic number and square it, it's like, you know, way more gigantic. At that point, subtracting 4 times the gigantic number and then adding this measly little 5, it doesn't even affect it. Because you made it so big, this stuff doesn't even matter. You take a gigantic number raised to the 5th power, I mean, it's freaking enormous, and then you add 17. Like, is the 17 really going to have an impact at that point? You know what I mean? It's like you got this giant pile of sand, and you're like, here's one more. So you cross off every term that doesn't involve the higher power. So the squared is the highest power on top, you cross off everything else. The 5th highest power on the bottom, you cross off everything else. And then if you think about it, and I think Miss Mahaney, now that I remember, might have made you actually do this. I'm not going to make you do it, which I'm glad she did, but you don't have to. If you think about it, couldn't I reduce that to 3 over x to the 3rd? Like if I just take an x squared out of both of them, isn't it 3 over x to the 3rd? Yeah. Okay. So now, I'm going to write this out. You don't need to. I'm just trying to show you again. So what's 3 divided by 10? What's 3 divided by 100? What's 3 divided by 1,000? 3 divided by 10,000. So when the number on the bottom gets bigger, what happens to the overall value? It gets smaller. Well, I'm putting in a gigantic number, and So what is this that we're doing here? What is that going to approach? It's going to approach 0. So if the higher power is on the bottom, higher power on the bottom of the fraction, there is a horizontal asymptote at y equals 0. And you guys know some equations, if you remember, you know some equations like this. Like, do you know what 1 over x looks like? I think we did this the other day. That's a hyperbola, so you get like this scenario. You see how y equals 0 is a horizontal asymptote there? Where's the higher power in that equation? On the bottom. So, you know, as x gets bigger and bigger, 1 divided by that gigantic number gets smaller and smaller, and that's why you're approaching the axis or y value of 0. Is that okay? Second scenario. Highest power is the same on the top and on the bottom. So, for example, y equals 6x to the third plus pi over y equals 12x to the third minus 6x minus e. So I would say, again, look at only the term with the highest power. So I take some gigantic number, cube it, multiply it by 6, and then I'm like, oh, here's 3.14. Like this is not relevant. These are not relevant. You only look at the highest power. Now take this, what's left, and reduce it. What are you left with? 1/2. There's not even x's anymore. So x doesn't matter, so I don't care what x is. Like, as x gets bigger and bigger and bigger and bigger, who cares? What's this value going to be all the time? So if you plug in a gigantic x value into this, there's no x to even plug into, so you just get a half. The higher power is the same. There's a horizontal asymptote at y equals, I'm going to say like y equals the coefficients. Does that make sense what I mean by that? This would be like at y equals 6/12. And then the third scenario would be the highest power is on the top. And if the highest power is on the top, if I look at an example of that, like y equals x to the third minus 1 over x. Again, the minus 1 doesn't make a bit of difference. So this just turns into basically y equals x squared, doesn't it? Does y equals squared level off at any point, or does it just go up or down forever? And it's a parabola, right? So does that level off? It just goes up forever. So in this case, there would be no horizontal asymptote. Your limit will be either positive infinity or negative infinity, depending on, you might have to like plug in, or imagine plugging in a giant number and seeing what would happen to the sign. So for example on that, let's say, limit as x approaches negative infinity of x squared minus 4 over x. First of all, where's the higher power? On the top. So is there going to be a horizontal asymptote? No. But that I that means my answer is either going to be positive infinity or negative infinity. But I need to figure out which one. So you just kind of think through plugging in a big negative number. If I plug in a big negative number here and square it, what happens to the sign? It turns positive, and subtracting 4 is not going to make a bit of difference. On the bottom, when I plug in a gigantic negative number, what's the sign? Negative. So don't I have a positive divided by a negative? So my answer is going to be negative. So sometimes you have to think through the positive negativeness of it all. Questions there? One more thing we got to worry about is you have to simplify before you plug in. You just have to simplify the highest power. I'll show you what I mean. That makes your life a little easier. Simplify the highest power before plugging in. So for example, y equals the square root of 9x to the 6th minus 16 over x squared minus 4 times 4x plus 1. And I say to you, find horizontal asymptotes. Find any horizontal asymptotes. You can't compare the powers until you simplify. So this highest power is inside of the square root, so it's not like it's in a true state, and I have to simplify that part. These highest powers are like separate, like you got factors, so I have to kind of put it back together before I compare the highest powers. So I don't care about this. I don't really care about these, but I have to care about both of those. The bottom's easier. So when I FOIL the bottom, what will the term with the biggest power in it end up being? Well, it'll be 4x cubed, won't it? Like the highest power is x cubed, I know, but if I FOIL, when I get 4x to the third, and then blah, 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 after that, I don't care about the blah, 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 and I do care about the 4x to the third. What's the square root? I'm going to change this because I need to check something else. Make that 6 a 16. What's the square root of 9x to the 16? 3x to the 4th or 8? It's 8. If you don't believe me, look at it this way. What's 3x to the 8 times 3x to the 8? Well, 3 times 3 is 9. And what do you do with these two powers? You add them. So if you told me the square root of 3x to the 4th, what's 3x to the 4th times 3x to the 4th? 9x to the 8. That doesn't match, right? So the rule with this is you take half of it. You multiply by half because you're raising it to the half power technically by square root. So don't square root that. You square root the number, but you don't square root the power. Okay, where's the highest power here? On top. So if I asked you to find horizontal asymptotes, you would just say there's none. If I asked you to find, let's do it that way too. Find the limit as x approaches negative infinity of that. Take a second to do it. So you're thinking through the sign is what I'm trying to get you to practice. So if I plug in a gigantic negative number on top, does it come out positive or negative? Positive. On the bottom? Negative. So my answer would be negative. Does that make sense? Questions? Yeah.
Okay, I have no idea how you did that last.
Take a huge, let's say take negative 1,000.
Okay.
The number doesn't matter. If I raise a negative number to the 8th power,
Yeah.
does it end up positive or negative?
It ends up top. Because
Because it's an even number, right? Do it on the bottom.
it ends up
Then
negative.
it's a negative. So I know that if there's no horizontal asymptote, my answer is going to be either positive or negative infinity.
Okay.
And then I just figured out the top's positive and the bottom's negative. So positive divided by negative gives me negative infinity.
Okay.
Alright? Alright, I'm going to write like 5 of these, just real quick here. Have you do them, we'll check them, and I'll get your own. That's just a scribble. That's not a number. X squared. Those four. So I'll pass on your homework while you're doing that, and then we'll check those. And there's in the folder. This is in the folder, so if you lose it, the answers are on here, so you won't have to look at the folder for this one. Well, so where's the higher power? What you're saying. It's only positive or negative. Yeah, this is. 13. What do I have? 1102?
Yeah.
Hurry up. Go faster. Go. So the way you write your answer matters, and it depends on the way the question is phrased. Like in number one, if I said, what is the limit? So first of all, the math, this would be 4x squared over x squared, right? Just look at the higher power. So if I said, what is the limit? Your answer is 4, and that's what I said, so your answer is 4. But what if I said, where's the horizontal asymptote? You can't tell me 4, what would you tell me? Y equals 4. So you have to, if I ask for an asymptote, you have to give me an equation. We said the same thing about vertical asymptotes, right? You have to tell me x equals whatever. But if I just ask for a limit, you just need a number. Number 2, if I simplify, this would be 4x to the 18th on top. This would be x to the 18th on the bottom. So what's your answer? 4. Highest powers are top. Where's the higher power number 3? Bottom. What's the limit? 0. Where's their horizontal asymptote? Y equals 0. So like it's the same concept, just the way you phrase your answer matters. And this one I'm asking for horizontal asymptote, so you're going to give me your answer as an equation. So this would be 3x squared on top. If I simplify the bottom, what do we get? 3x squared. So where's your horizontal asymptote? Y equals 1. And again, if you just tell me 1 in this one, it's not right. Because I'm asking for an asymptote. That's a line that has to. How many got all 4 of those? Alright, I feel it's a little rushed, but hopefully you guys are okay. So that's your homework. I'll come around and grade it. Or will I? I don't know. But we'll
I'll
keep
show
cruising.
you on Wednesday.
Oh yeah. You're skipping the next month anyway, so we could.
Yeah.
You're Wisconsin fans? Or are you not sure?
Well, I'm planning for one now.
Oh, are you? Oh, well, then you could be a fan.
Either there or
Really? What? Why those two?